So today what I'd like to look at is some materials from section 3.2, probability using the multiplication rule. So in the multiplication rule, one of the first things we have to do is understand how to determine probability. So remember, the probability of an event is equal to the number of outcomes in the event divided by the total outcomes in the sample space. So again, remember, the number of outcomes in the event is basically what I want, and this is my desired outcomes, if you will. Now, when we get into the multiplication rule, this is also sometimes known as the AND rule. So if you see this word AND, it kind of implies that we're dealing with this multiplication rule. So if we have the probability of A and B, there's two formulas. One of them is you multiply the probability of A times the probability of B. We use this if they don't affect each other, they're independent of each other. So then we have the probability of A and B, and that's going to be the formula that's going to be the probability of A times the probability of B, given that A actually has happened. So notice how we'll be multiplying these probabilities together. So this is kind of our big formula up here, and then this kind of moves into 3.2 with these multiplication rules. So let's look at example 7 and see how this fits into our math. So we have a table given to us. So the question involves the accompanying table shows the results of a survey, which 250 males and 250 female workers are ages 25 to 65 were asked if they contribute to a retirement savings plan at work. Complete parts A and B. So if you notice here, males 110 contribute, 140 do not contribute, for a total of 250 males. The females 134 contribute, 116 do not contribute out of 250 females. So the totals are then there's 244 employees who contribute, 256 employees who do not contribute out of like 500 employees. So the first question says, find the probability that a randomly selected worker contributes to a retirement plan at work, given that the worker is male. So notice how, given that a worker is male, that's that vocabulary that we've been picking up on. So given that the worker is male means this has happened. So now we're locked in that this is what's happened, is we're only talking about the male side of things. So what we want to do is find the probability that a selected worker contributes to a retirement savings plan. So notice the other thing we have is contributes to a retirement plan. So what we're basically boiled down to then is we're trying to find the probability who contribute, but they have to be male. So the event I want is the males who contribute, and there are 250 males in that sample space. So the way this turns out then is it's going to be the 110 that are male then contribute, but then there's only 250 males in that. So that's going to be our math in this problem. So basically all this is this is basically the probability of contributing given the person was male. It kind of looks like that if I'm using words. So if I do the math, 110 divided by 250, that gives us then this 0.44. So we don't have to round that one. So 0.44, so around 44% of the males contribute to a retirement savings plan. So the next example says, find the probability that randomly selecting a worker is female, given that the worker contributes. This again is the key part. This is what's happened given that the worker contributes. So if I go back up here to my problem here, let's erase this. Now they're saying contributing has happened. So now we're focusing on that. And what we want to do is, of those who contributed, we want to know what the probability of selecting a worker that is female. So in this group, what we're picking up on is there's 134 females out of the 244 who contribute. So that would be the math involved here. So that's the desired outcomes is the 134, and my big sample space is the 244 that have already contributed. So if I go 134 divided by this 244, this gives me now, probably have to round to 3 decimal places. So it's going to be 0.54, looks like 9, because that 1 up here would say keep the 9. So right around 54.9% of the females contribute to a retirement plan. Okay, so that kind of takes care of that example.